Let's talk about 5 ways to detect outliers and 3 ways to detect influential points. If you have not watched the video where I explain what these points are, make sure to watch them out. The first method to detect outliers is called an interquartile range method. Take the difference between the third and the first quartiles and see whether a point is more than 1.5 times above the third quartile or this much times below the first quartile. Then it is an outlier. The second method is called the z-score method. Simply plot the distribution of the points, and if it is falling more than 2.5 times the standard deviation on the right or the left, it is an outlier. The third way to do this is to use standardized or studentized residuals, basically how far the point is from the regression line. The fourth method is using single outlier tests, which detect a single outlier and only one outlier in the entire data set. Now, these suffer from the issue of masking, where if there are multiple outliers, then none of them would be detected as such. To tackle this, we have a generalized extreme studentized deviation test. It's a mouthful, but it's called generalized EST test, which can detect for outliers more robustly. Now, let's talk about 3 ways to detect influential points. The first one is called Cook's distance, right? If you remove a point, how much is your y value changing? That's a Cook's distance. The second way to do is DFFITS, which is again looking at the fit of the data after you remove a particular point. And the third one is called DFFITS, which is how much the slope of the regression line is changing.